fraction division, we're going to focus on whole divided by unit fraction. So a lot happening on this page, but what I want you to focus on is this. There are two ways to do division or to think about division, and one is to divide by the number of groups you want or the size of groups you want. And when you're dividing by a fraction, it's much easier to think about this bottom portion where we're saying that we're dividing by the size of the group we want. It's easier to think of a half-size piece rather than a half-size group, which kind of doesn't make sense. So imagine taking things and chopping into 1/2 size pieces. That kind of, you can picture that. So put into words, we're going to again use this bottom one here. We're going to take our total and we're going to divide it by the size of groups we want, whatever that fraction is. And our answer is going to be the number of groups we end up with. Okay, so let's take a look at some examples. So we're going to look at this first section up at the top here. We're going to have 2 candy bars. Now we're going to do 4 examples here. You can see these are set up, but we don't have anything we're dividing by down here. We'll get to that in a moment. We're going to start with a very simple division problem. In fact, there's no fraction in this division problem. It's just 2 divided by 1. Probably one of the first and easiest division problems you ever did. Simply dividing by 1. So when we do that, we're going to think about taking these 2 candy bars that we're starting out with and dividing it into groups that are 1 candy bar in size. Well, here's one and there's another. Our answer is going to be the number of groups. We end up with 2 of them. You get 2 pieces that are 1 candy bar in size. Now, that's pretty basic, right? Let's go ahead and apply that same verbiage and that same idea to a fraction problem. Okay, so this time we're going to divide these 2 candy bars, starting out with the same number of candy bars each time, into 1/2 candy bar size pieces. So if you can imagine taking these candy bars, we now split them in half, and we're going to count the pieces. 1, 2, 3, 4. Our answer is going to be 4. You're going to end up with 4 pieces that are 1/2 a candy bar in size. So continuing with that theme, we're now going to do the same thing with 1/3 size pieces. Chop each whole, which we have 2 of them, into 1/3 size pieces. Count them up. We end up with 6. 6 is our answer. You get 6 pieces that are 1/3 candy bar in size. Okay, moving on to the next one, we're going to do the same thing here, and we'll end up with 1/4 size pieces. Chop each one into 1/4 size pieces. We end up with 8. 8 is going to be our answer. You get 8 pieces that are 1/4 candy bar in size. So you'll notice that as the fraction gets smaller, the pieces that we're dividing this into get smaller, we end up with more of them, which makes sense because if you chop things into smaller pieces, you're going to end up with more of them, more pieces. If you have larger pieces you're cutting it into, you're going to end up with fewer of them. Okay, so let's apply that to a number line. We can use a number line just like we did those models before, and also use a word problem. Jillian is making bracelets out of ribbon. She has 3 yards of ribbon left. To make a bracelet, she needs 1/5 yard size pieces. How many bracelets can she make with her remaining ribbon? Okay, so the first thing you want to do in any division problem, whether there's fractions or not, is identify your total. Identify what is getting split up. In this case, it's the 3 yards of ribbon she has left that's going to get split up. So we're going to go ahead and put that up on our number line, and that's going to be our first number. And that's what we're going to be splitting up. So next, how are we going to split that? Well, this section right here in yellow tells us that we need to cut it into 1/5 yard size pieces. So we have our yard pieces here, and we need to cut it into 1/5 of a yard size pieces. So we're going to be dividing by 1/5. So now we have our instructions for how we're going to divide it. And we can go ahead and take each yard and divide it up into 1/5 size pieces. And the number line kind of helps you do that. Okay, we count those pieces up. We end up with 15 of them. So 3 yards is going to give us 15 of these 1/5 size pieces. And that's going to be our answer. And you can use anything you want. You can use kind of the bar model that we have up there. You can use little jumps. As long as it's the correct fractional size jumps, it really doesn't matter how you represent that on the number line. You'll still end up with the same number. Now, we have 15, that's great, but we need to make sure we don't forget to give meaning to our numbers. It starts getting kind of confusing. So 3 is going to represent our 3 yards of ribbon. 1/5 is representing the 1/5 of a yard it takes to make a bracelet. And the 15, well, to figure out what that is, we need to go back to the question. How many bracelets can she make with her remaining ribbon? So that kind of tells us 15 bracelets is going to be how many she can make. Now, why does this all seem like multiplication? I'm glad you asked, because it basically is. Now, let me explain. Okay, but before I get into that, I want to explain what the word reciprocal means. Reciprocal means the inverse of something, which is a little bit like the opposite, not exactly, but it's going to be kind of the reverse of something. So we're going to take the reverse of the fraction, 1/5, and it's going to be 5/1. We flipped it. Okay, and 5/1, well, we remember fractions are just unfinished division problems. 1/5 is 1 divided by 5, so the opposite of that would be 5 divided by 1. And anything divided by 1 is itself, so 5 divided by 1 is 5. So the reciprocal of 1/5 is 5. Now, why is that important? Well, it's going to come up in this next part here. Okay, so let's take our original number sentence here. 3 divided by 1/5 equals 15. We already had that all figured out. But let's figure out why this did kind of seem like multiplication. Because if you look here, every time we had a whole, we ended up with 5 pieces. Here's 5, here's 5 more, and there's 5 more. So 5, 10, 15. Seems like 3 times 5. Let's see. Okay, we're going to do this with something called keep, change, flip. Keep, change, flip. Okay, and what that means is we're going to take the 3, the first number, and we're just going to keep it. Nothing fancy, keep that number. Then we're going to change the sign. So we're going to change the division sign to a multiplication sign. And we're going to flip using the reciprocal. So we're going to flip 1/5, and we already figured out that's going to be 5. And that's where we end up with our 3 times 5. It's going to equal 15. Same thing. So why in the world, if basically all this mess was just doing 3 times 5, why did we have to do crazy division with fractions? Well, it's not so bad when you're doing unit fractions. A unit fraction is a fraction with a 1 on top, which means we have one piece of something. But you're going to be doing division that is not a unit fraction, like 2/5, and it's not as simple as doing just 3 times a whole number. You have to do 3 times, that would be 5/2, 5/2, and it gets a little bit more complicated, but it's very doable. And if you can remember the keep, change, flip, you can use that moving on.